Hello, welcome to the video notes for lesson 3-4. This lesson is about exponents and multiplication, numbers only, exponents and division, numbers only. Okay, so this lesson begins on page 18 in your notes packet. The learning target for this lesson: I can use the properties of exponents to multiply and divide numbers with the same base. Now, you'll see a picture here that shows you the large number. When we see a problem, a term that has exponent, the large number is called the base. And then you all should be aware that the small number is the exponent. Alright, so we are going to take a look at some examples on page 18 and see what happens, what really happens when we multiply these out. Alright, so if I'm going to multiply 2 to the second power times 2 to the third power, what I really have is 2 to the second is 4, 2 to the third is 8, multiply those together and you get, actually I'm not going to put a brownie pan there, and what you really get is 32. Now think about what this is. We have 2 times 2, and then I'm multiplying that times 2 times 2 times 2. Now, what do we really have here? Well, we're going to see this, hopefully recognize a pattern or something that's happening. 2 times 2 to the 4th. By the way, if you don't see an exponent, you can pretend that there is an exponent of 1. So this is really 2 to the 1st. So really what we have is 2 times 16, and 2 times 16 is 32. Now, another way we can think of this is 2 times 2 times 2 times 2 times 2. Again, hopefully you're recognizing that there is a pattern to this. There is something that is occurring over and over again. 2 to the second times 2 to the second times 2, or 2 to the first, is 4 times 4, which is 16, times 2, which is 32. Again, so now we have 2 times 2 times 2 times 2 times 2. Again, 5 2's. And here we just have 5 2's, which is 32. Alright, what do all these have in common? Well, no matter how you do this, you end up with 2 to the 5th power, or 32. Okay? Whoops, wrong number. So, what does that mean? Well, first of all, these are all equivalent. And the other thing that you need to recognize is when we have 5 2's multiplied together, you get 2 to the 5th power. Alright? Now, this is the answer in exponential form, and I'm going to write that again. When you have an exponent in your answer, it's called exponential form. Now, some of you may recognize what we are doing here with the exponents in each case. So when I had 2 to the second and 2 to the third, look what I ended up with. 2 to the first times 2 to the 4th. 2 to the second times 2 to the second times 2 to the first. All of these ended up with 2 to the 5th. I wonder what the pattern is, what's going on. I bet some of you have already figured this out. Alright, now let's take a look at an example of division. So now we have 2 to the 6th divided by 2 to the 4th. That is 64, 2 to the 6th is 64, divided by 16. And 64 divided by 16 is 4. Now another way to think of 4 is 2 to the second. Now I left some space here because I'm going to write this out. 2 to the 6th is 2 times 2 times 2 times 2 times 2 times 2 times 2. over 2 to the 4th. 2 times 2 times 2 times 2 times 2. Now what happens here? These 2's cancel out, and you end up with 2 times 2, or 4. Now, when you're saying, well, what's on the bottom? When these all cancel out, they all become 1s, so it's really 2 times 2 over 1, or 4 over 1, which, again, is 2 to the 2nd power. Now, look at the exponents here, and think of how you might have come up with this answer. The next one, 2 to the 3rd power over 2, is equal to 8 over 2, which is equal to 4. Again, we have 2 times 2 times 2 over 2. These cancel out. Really, we have 4, or 2 to the 2nd power. 2 to the 5th over 2 cubed is 32 over 8, which is equal to 4. I'm going to write this one out, but I'm not going to write out the next one because that is just way too many 2's. But I think you're getting the idea here. We have a pattern. When you look at the exponents, now it has to do with the base. The bases are the same. And what happens is, we have to do something with these exponents to get our answer. And over on the next page, page 19, is a little more of an answer for you, or description. So on page 19, multiplying powers with the same base. To multiply powers with the same base, add the exponents. That's the big idea here. So if I've got 7 to the 2nd power times 7 to the 3rd power, think about what that is. That's 2 7s times 3 7s. So you have 5 7s, or 7 to the 5th power. All right? So here's another example. 6 to the 4th times 6. Remember, when it's just a number, it can be to the 1st power. So what's 4 plus 1? 6 to the 4 plus 1 is 6 to the 5th power. Now we are leaving our answers in exponential form. So, in other words, we're not turning this into the answer 6 to the 5th power. We would need a calculator to do that. But you don't need a calculator to add these exponents. Okay, the next one, we have the base is the same for all of these. 5 to the 7th times 5 to the 6th times 5 to the 8th. So really what we have here is 5 to the 7 plus 6 plus 8 power. So when you add those up, you get 5 to the 21st power. Now the next one, be careful with this. These two have the same base. This one does not. So because this does not have the same base, you may not combine them. So what we have, we can combine the first two. 3 to the 2nd times 3 to the 2nd is 3 to the 4th. And then times 8 to the 4th. And you're just going to leave your answer like this. Or you could actually turn these into their answer, their expanded form, but those would be very large numbers, and we're not going to use a calculator, so we're going to leave it like this. But just make a star here, and remember, the bases are not, so since these are not the same base, do not combine. You can't combine them if they don't have the same base. You just leave them in exponential form just like that. Okay, one more problem to do, or one more big idea here. Dividing powers with the same base. To divide with the same base, you subtract the exponents. Alright, so I've got 7 to the 8th power over 7 to the 3rd. I do 7 to the 8 minus 3 equals 7 to the 5th. Okay? So, here we have 6 to the 4th over 6 to the 3rd power. So it's really 6 to the 4 minus 3, which is 6 to the first power, or just 6. You do not need to include the 1 if that's your exponent. The next one, 5 to the 7th over 5 to the 3rd. Oh, so you are subtracting the numerator minus the denominator when you do this. So whatever it is, x, you're going to subtract the numerator minus the denominator. So write that down so you remember that, hopefully. So, alright, so 7 minus 3. So 5 to the 7 minus 3 means 5 to the 4th. Okay, the next one. Now, we have multiplication in the numerator. So first we have to do that. Now, 4 times 4 to the 2nd is 4 to the 3rd power. We add those exponents. Remember, there's a 1 there. Over 4 to the 6th power. Now, watch this. Numerator minus denominator. 4 to the 3 minus 6. Well, what is 3 minus 6? That is 4 to the negative 3 power. Now, for today, we are going to leave it like this. But usually we don't like a negative answer as our exponent. So we're going to talk about that later on, what we're going to do to make it a positive exponent. But for now, we'll just find the exponent, even if it's negative. All right? That's it for this video. If you had any trouble, go back and rewatch it, or come and see me for help. Good luck, and we'll see you in math.